Hi guys, welcome back to this next tutorial. We've done hit scan weapons, we've done projectiles, and now we are going to start working on unifying the physics behavior between these two. I'm shooting this box and I'm using a combination of hit scan weapons and projectile weapons, and the box is reacting to both. Now, this might not seem that important. You might be more concerned about shooting enemies, but since we are shooting a rigid body, I thought it was a good time to sort of highlight how we can unify these two. It doesn't take long and it makes a huge difference in the way your game looks. So let's jump into our project and take a look. Here we are in our project, and if we run the game as it is, you can see our hit scan weapons don't do anything, but our projectiles certainly do. Okay, so how do we go about fixing this? Well, if we jump into our box, we can see that we've got a simple hit successful function that takes the damage and applies it to the box. If it reaches 0, then we call queue_free and it disappears from the scene. The function that is controlling that at the moment in the hit scan branch of our weapon system is a function called hitscan damage that gets called after a collision is detected via our hitscan collision function. And right now we're just passing in the collider, and we're checking that if it's in a group called target and if it's got the function called hit successful, we're going to call that function and pass in the damage. So not a lot to go off, but we can use some of the information from our collision to work out the direction it should be moving. So we need to pass in a couple of extra parameters, and we'll name them here. We'll call one direction and the other we'll call position. Okay, and I'll just come back up to where we're calling that function and I'll write bullet direction. We've already got that at the very start of this function. We've got bullet direction equals the collision point minus the bullet point dot global transform dot origin normalized. So that is the direction of our hit scan. So that's essentially where the bullet is coming from, if there was a bullet. And the next thing we need is position. Now we can get this from the bullet collision dot position. This is a field that's returned from the getWorld3D.directSpaceState.intersectRay function. It's something that is returned when that collides with something, and it's the world position. We'll jump into that function here, and you can see that is the intersection point. So that is where that position is in the world space. And we can use that to determine the position of our target. Now, if we come back into here, passing in both of those, and what we need to do as well is where we're passing in collider.hitSuccessful, we also want to pass in the direction and the position. All right. Now we just need to jump back over into the box and update the hit successful function here. Here's a little trick for you. I'm going to write underscore direction colon equals vector3.0. And what that will do is actually make these parameters optional so that we can still use it with our rigid body projectiles that we're firing, and we can reuse this function on other targets that might not need this information. And the next one that we need to call is obviously position. And we'll do the exact same thing, underscore position colon equals vector3.0. Okay, so we'll do a quick run of the game here, and just to show you that we haven't changed anything. We're passing in those functions, and our shooting in this game hasn't changed at all. So everything is still working. Those are all optional parameters. Our projectile is just passing in the damage, and the rest is all just going to be 0. So we can come down here and we'll need to create a new variable called hit underscore position. And this will be a little bit of math here to work out the position of the actual hit. And it'll be equal to underscore position minus get global transform dot origin. And we'll come down at the bottom of this function and we'll say if underscore direction is not equal to vector3.0. So we're just going to only run this if there is information being passed in. Otherwise, we're not going to do this. And we'll call the function apply impulse. And this will do exactly what it says on the tin, really. It's going to apply an impulse, which is a force at the position, And so our impulse is going to be, or at least the way I like to do it, so that it sort of scales with the power of the weapon, we're going to call direction, and we're going to multiply that by damage. Now, the reason that the impulse is going to be in the direction is because we want that impulse to be in the direction of the bullet. So essentially, that's why it is direction for the impulse, and we're multiplying that by damage to sort of give it a little bit more oomph depending on the weapon or whatever it is. And then the next is going to be the position, which we calculated at hit position, so I'll pass that in. And that's all we need to do. We can run the game, okay? So you can see now that the box is reacting to the hit scan weapon and it's disappeared. Might add some health while we play around with this, just so it's a little bit easier. Okay, you can see me lay into this. It doesn't matter where I shoot it, it seems to react in a sensible way, which is exactly what we want. And you can see if I shoot it with the projectile weapon, obviously there's a lot more force behind that, but this is something you can tweak. You can change the mass of the bullet to sort of give it less force. And so we can jump back into our project and do that so that it feels similar depending on the gun. It's just going to depend on what you're trying to do and how you want things to react. But you know, that's the function you need to do. I'm not sure if it's 100% physically accurate, but it's good enough and it's easy enough to implement, right? And since we're, you know, shooting this rigid body, I thought it was a good time to show you. So we can come back to the bullet and we can reduce that mass from 0.1 kg to 0.01, so it's a very light bullet. And we can rerun that, and then, okay, that feels pretty comparable, I would say, to what the Hitscan done. Is a little bit more, but I don't think people would really notice that much. So now you can shoot rigid bodies with both weapons and they react the same, which is pretty cool. Now, while we're here, I think we should just add in a static body. So I like this particular mesh called target B. And I'll come back into the project and I'll create a new scene by clicking on this plus. I'll press other node and I'll search for static body 3D and I'll drag that model into the scene. I'm going to right click and make local, get rid of all these extra nodes and delete them. And then I'll click on the target. I'm going to be a little bit lazy here and just go mesh single convex collision assembling. This isn't the most efficient way to create a collision shape, but it certainly is easy. Now I'll save this here in the tutorial folder and I'll just call it something like target. I'll reset the position because everything is a little bit off, so I'll just change that, make sure it's on 0. And I'll rename this static body to be something like target. Okay, so we'll create a script next and we'll save it in the tutorial folder and we'll call it something like static underscore target, and we'll create that. And we can pretty much just copy the code from our rigid body. I'll just copy this first bit. We don't need as much because obviously it's not going to react to the direction and position, but we do need it because it's getting passed in from the player. So we'll bring that over, copy it, and I'll just enter down here and I'll paste this in. And right below this, I'm just going to write pass for a second and I'll create a variable called health like before, except this time it's just going to have 1. And under hit successful, it'll pretty much be what we started with the box. We are going to subtract the health. So health minus equals damage. And if health is less than or equal to 0, then we will keyfree. Nice and simple. That's all we need, but we do need to pass in those 2 optional variables just to keep our player character happy. If we don't do that, this will crash. So I'll add a node to the scene and I'll just call it static targets. And I'll navigate to that folder and I'll just add that to the scene. Okay, I'm gonna drag it over to this wall over here just so that we have something to shoot at. Okay, it's nice and positioned on the wall. I'll raise it up a little bit and I'll just duplicate that a few times so that we've got something to shoot at. I might skip this section because it's kind of boring. Okay, and before I forget, we do need to add this static body to our group called target. So I'll open that scene again and I'll come over to the node tab on the right hand side where it says inspector node history. I'll click node and I'll click groups here and I'll click manage groups. I'll type target, add, click the static body, click add, click OK. And that's all we need to do. Just save that scene. Make sure it's the same as the one for the box. You can have multiple groups if you want, and you could be calling different functions on those as well. That's totally fine if you want to do it this way. I'm just running them both in the same group and having the exact same function be called. All right, so we have a look at these and you can see that they're getting deleted successfully. All right, so that's how you add in physics reactions. It's how I like to do my static bodies as well. Just a nice, simple way of dealing with targets, having a single function that's being called and the two variables that aren't required all the time be optional. There's plenty of other ways to do this as well, so if you have a better one, feel free to share us down in the comments and maybe I'll cover it at some point. Other than that, guys, this has been another episode in our series on how to create a full FPS weapon system. If you're enjoying this series, I really do appreciate a like, and if you want to watch out for the next one next week, remember to hit subscribe. Of course, if you want to get all early access to any of these videos, you can head over to Patreon, patreon.com/chaffgames, and you can get these episodes in advance if you don't want to wait. Anyway, that's all for this week. I'm Isaac from Chaff Games, and I'll see you next time.